Okay, good afternoon, everyone. Welcome to our lesson 18 math video. This is actually just going to be a pre-video introducing you to some of the vocabulary that we're going to be seeing in lesson 18, which is really the start of a new math unit. As you guys can see, this is part of our special home study week video set, and I'm actually filming it live from my house. This is where I live. Probably a lot of you have not seen my house before because, you know, I haven't taught out of it previously, but, you know, basic, you know, we are in the middle of a lockdown quarantine, so you can see there's not a lot of people on the streets. And some people aren't respecting it, they should. But, yeah, I'm glad to have you guys here with me today, and let's explore lesson 18. And mostly I just want to go over 3 main vocabulary words today, which are... Oh. Lost a marker. Get a new one. Okay. Well, the 3 main vocabulary words that we're going to be examining in this video are complementary angles, supplementary angles, and vertical angles. These are really, it's kind of a review of 6th grade concepts, but they're going to come up a lot in our 7th grade textbook, and so we should have a quick review of them. And let me tell you about each of them. I'm really sad that I'm missing my marker. You know, I can't just go buy a new one these days. Should I leave it outside? So, let's go over each of these. Complementary angles are angles whose sum is equal to 90 degrees. Okay, complementary angles are, you know, together they're going to form a right angle. So if I have, you know, like this angle, and let me see if I can do it. They don't have to be like this angle. And if I tell you, oh, this angle over here is 30 degrees. Okay? And this angle is complementary with this angle. So we know that together they're going to equal, you know, like this angle plus this angle are going to equal 90 degrees. Well, just because we know what the word complementary means, we can figure out what the missing angle is, which in this case would be, you know, 90 minus 30 is 60 degrees. Okay, so that's complementary angles. Supplementary angles, you know, they kind of match the theme. It's just angles whose sum is equal to 180 degrees. And again, you can use this all sorts of ways. Most typically, it'll be like, here's 2 angles. They are supplementary. What's the missing angle? Okay, so we're going to use that in action in a couple of problems. And the last vocabulary word we're going to practice today is vertical angles. Vertical angles are 2 non-adjacent angles formed by a pair of intersecting lines. Vertical angles are identical. But let me explain this one a little further, because I think vertical angles needs a picture. Okay. Vertical angles work like this, and I have 2 lines. Okay. So as you can see here, I have 2 lines. They are a pair of intersecting lines. There's these 2 lines. They are intersecting. That means they are crossing each other. And are there any vertical angles? Well, are there any non-adjacent angles? Let's go over that word. Non-adjacent. What does non-adjacent mean? Well, adjacent means next to. So non-adjacent means, you know, not next to. So in this case, I actually can see a few vertical angles. This angle up here is a vertical angle with this angle down here. Okay, and I know that because, again, they are non-adjacent. They are not next to each other. Right? This one is not next to this angle. Like these 2 angles. Oops. These 2 angles, let me erase that one, are adjacent. So those aren't vertical. And like these 2 angles, those are adjacent too, right? They're right next to each other. That's not what we're going for. These 2 I'm going to show are identical with this line. Okay, I know that they are vertical angles and they are therefore identical to each other. Oh, uh-oh. Sometimes when I drop things on my floor, I can't reach it because, there we go. Moving on. Let's give another example of that though. If these two angles are vertical, did you know that this angle over here is also vertical to this angle over here? And to show they're identical, I'm going to put 2 lines because I already used the 1 dash right there. So this angle and this angle are vertical. They are identical to each other. If I told you that this angle over here is, I'm going to make up a number, 75 degrees, you could easily tell me that this angle over here, I'm like, what's that missing angle? What's that red angle over there? Well, it's also 75 degrees, because that is how vertical angles work. Okay? Fun, easy. Let's try these out. So, angle ABC and angle XYZ are complementary. Okay, what does complementary mean? Well, as a review, it's angles whose sum equals 90 degrees. The way I remember that is, it's often a right angle is complementary when you put them together, so you'd complement it. What a nice right angle. So structured and sharp and, beautiful. Complement that 90 degree angle. I don't know if that's going to help you or not, but I do know that these, in my problem number 1, this is our example problem number 1, angle ABC and angle XYZ are complementary. Angle ABC equals 33 degrees. What is the measure of angle XYZ? This seems like a simple, subtraction problem. If we know that together, these two are going to equal, 90 degrees, and we know that one of them is 33, the other one is 90 minus 33. So let's do that. 90 minus 33. And it is 57, I think. Yep, 57 degrees. Okay, and that's why we need to learn these vocabulary words, because often they'll assume that you can find, whatever's missing, because you understand that complementary means 90 degrees. Let's go on to our second problem. Here we can see 2 intersecting lines. The lines I have here is, this OR line, it goes through the point T, and this other line, HS, which again intersects with line OR at point T. And we have a couple of facts here. I know that angle HTO is supplementary with or to angle OTS. Let's break down what this means. First, where is angle HTO? HTO, you read it like this. You find the first point H here to T, so it goes over to T, and then to O, so up here. Okay, so that angle, whatever that is angle HTO, that's this angle, which is supplementary to angle OTS. Let's find that angle. So I find point O, here it is, O to T to S. Okay? So we know that this angle over here, OTS, is supplementary to HTO. And, so what does that mean? It means that together, this angle and this angle are going to equal 180 degrees. Oh, I forgot to say, my mnemonic for supplementary angles, when I was a kid, I remembered this because I know that 180 degrees, when you draw it out, is a straight line. Whenever you have supplementary angles, if you put them next to each other, you'd see that, together they make a straight line. So I think of it like a piece of... See if I have any wood in my house. A straight line. See, a supple piece of wood. Supple means like a soft, flexible piece of wood usually. So I think of it like, oh, look at this supplementary angle made out of wood. Hopefully that's helpful. I don't know. Okay. So supplementary angles whose sum equals 180 degrees. These two together will equal 180 degrees. Let's keep moving though. And they give us a number, which is that angle STR equals 70 degrees. So let's label that STR. This angle right here is 70 degrees, okay? And they want me to know how much is each angle. Like, how much is all the angles? Like, let's label each individual angle. Well, we have a few tricks and tools now, which is the fact that I see a pair of vertical angles. So vertical angles, again, is two non-adjacent angles. It's when they're like across from each other, and they are going to be identical. So if angle STR is 70 degrees, the vertical angle to it over here, HTO, must also be 70 degrees. Nice. That was like no math at all. Okay. And then we can find this angle, OTS, because we know these two together, we know that this angle and this angle are going to equal 180 degrees because they are supplementary. So I can just say 180 equals this angle here, 70 plus this angle, which we'll just put x for now. And I need to solve for x, so subtract 70 from this side, subtract 70 from this side, and I get, you know, x equals 110 degrees, okay? So now I know that this angle here is 110 degrees, okay? And all I need left to find is, let me show that, see how these two are identical again. I'm going to put a dash mark here to show they're identical. Let's show that, you know, this angle and this angle here, what angle is this? This is HTR, or you could call this angle, you know, RTH. But that angle, I know, is vertical to this angle. So it's going to be identical, 110 degrees. Nice. So that is the answer there. We've solved all. Oh, another math problem. As you can see, oh, my black pen! There you are. I had to film this whole video without you. You're the most important of the markers. See, this is why you gotta clean your house. I'll probably spend my time tidying since we have so much house time these days. Here is an interesting one. I can see I have two angles, which I did not bother to label, but we'll call one angle A, and this angle over here is angle B. Right off the bat, I can see that angle A and B are, what is this, a right angle? So, you know, like together, they are a right angle, which means they must be complementary, right? Their sum is equal to 90 degrees. So, and in this, you know, problem, presumably the question is, what does x equal? Okay, and I can see that angle A is 40 degrees, and angle B is 3x plus 10 degrees. This crazy, you know, long amount, but we can solve this. It's not undoable. So here, since they are complementary, we know that, you know, angle A plus B are gonna equal 90 degrees, okay? And then, in fact, let's plug in what A is. We know A is 40, so I can say 40 plus, what's angle B? 3x plus 10 is gonna equal 90 degrees, okay? So you see how, you know, these two together are gonna equal 90. Alright, let's get that. Okay, let's move down. So first, let's combine like terms. 40 plus this positive 10 is going to make 50. So I can just, you know, plop those two together to get 3x plus 50 equals 90. Okay, 3x plus 50 equals 90. I want to move this 50 over, so minus 50 from this side, minus 50 from this side. This is like really similar to what we were doing last week. To get 3x equals 90 minus 50 is 40. And I have 3 x's, but I want one of them. So divide this side by 3 and divide this side by 3. And I get, oh, come on, eraser. Don't. Ah, there you go. So, back to this. I have 3x divided by 3 equals 40 over 3. Let's reduce that. So here I'm just going to write it. X equals 40 over 3. It doesn't really reduce out. I guess, best case you could write it as a mixed number, which you would get, I think, that's 40 divided by 3. 9, 10, 11, 12, 13, and 1/3. Okay, so I know that x is 13 and 1/3, assuming I did that math right. That 40 divided by 3 is that. Alright. Okay, thanks for watching this video. Hopefully you know what complementary angles are, supplementary angles, and vertical angles. Now, I will continue downstairs with some bonus content. As you can see, this is where I live. Teachers get paid tons of money, so I can pick anywhere to live that I want, and I've chosen this apartment complex. Here's my neighbors. Where is he? He's a little irritable. Yeah. Right. Let's keep going. Okay. Here's my pets. Oh, here's my pet. Hey, buddy. You want to do some more math? You want to do some math in this? Yeah, let's do something. Okay. Here's, I'm also a science teacher, so I've been writing down just some loose science while we're in quarantine. Maybe I'll invent something, I don't know. But, let's do a challenge problem. So in this challenge problem, we're going to have, let's have a couple of intersecting lines.